I am what some would classify as a citizen scientist. That just means I'm independent, not associated with any official research group. And the funding for my research and the work is done by myself. And a few years ago, I made a discovery with water and water electrons and how water can lose its electrons. And I ended up developing a process called electron extraction. Electron extraction opens the door for a number of sciences and industries, including health, chemical and material science, and new opportunities in energy. I'm sure you know what electrons are from science class. Within every atom, you have a nucleus, and there are protons and neutrons that make up that nucleus. The protons are positively charged, and we're taught that there's this negative subatomic particle that orbits the nucleus called an electron. A better word for it is clouds the nucleus. So electron extraction is the removal of that negative subatomic particle. One interesting thing about it is that the same principles that lead to making it possible also explain how charges are separated before lightning bolts are formed in thunderstorms. Up to this point, science doesn't know the specifics of how charges are created for lightning bolts to occur. They know some of the conditions that are present, and there are a number of theories involving ice losing their electrons, cosmic rays creating charges in clouds, but no one has truly ever solved the mystery of how charges are created in order for lightning to occur in what's called a cumulonimbus cloud. It's possible that cosmic rays and ice electrons may contribute to the charge, but primarily the charges are created by the water. Water is extremely unique, but we take it for granted because we're surrounded by it. Has a long list of anomalies compared to other liquids. Just get out your phone and Google what is the weirdest liquid in the universe. It's the most studied, but the least understood. It expands when it freezes, when other liquids contract when they freeze. It has an incredibly high boiling point. It has high surface tension. It's an excellent solvent. And under certain conditions, it gives up its electrons. And electron extraction creates those conditions. This is an electron extraction cell. There's actually one hanging up behind me. So what is taking place here? One way to describe it is when lightning is produced, in addition to water, there's also ice, cold air, rapidly rising warm air, and there's a clash of the warm and cold air. That area is where the water loses its electrons and becomes positively charged and continues to be propelled to the top of the cloud. And at the bottom remains the negative ions, or the electrons. And those charges build so much that the air can no longer insulate it, so those charges come together. Intercloud lightning. Sometimes the negative charge at the bottom of that cloud discharges on the ground, and that's what causes lightning strikes. Now imagine taking a slice of that cloud that I just described before the discharge occurs, shrinking it down to a miniature size and turning it upside down. That's what's occurring in an electron extraction cell. So you end up with a negative charge and a positive charge, or positively charged water. So how am I going to show you electron extraction is actually occurring in a video? It's different than if you were in person, but there are a number of ways I can demonstrate that I'm actually pulling electrons from water. One way would be to bring the charges back together in a spark gap. One way would be to send electrons to ground and let it light up an LED bulb. I could charge a capacitor and bring those terminals together and let you see that there's a discharge. But some people are going to argue that I'm using electrical components or batteries or electrostatic generators. So I believe the best way to demonstrate to you on video that electron extraction is taking place and I am removing electrons from water is by demonstrating the unique properties of positively charged water. So you know that positively charged water at the top of the cloud, the water that is missing its electrons. For all these demonstrations, we're going to be capturing the water by removing the bottom of the cell. Well, I remove the bottom of this electron extraction cell, and I'm going to be capturing all this water in a couple of different vessels. At first, we're going to be utilizing an extreme hydrophobic surface. It mimics the surface of a lotus leaf. Water doesn't actually sit on the surface of a lotus leaf because the surface creates a layer of air. So it is as if the water is actually floating. This bowl has been treated so that it creates the same properties. This gives us an idea of how water at the top of the cloud interacts with other droplets. But more importantly, today shows you that the water that comes from an electron extraction cell has a charge. And remember that opposite charges attract and like charges repel each other. Here is our first sample. Most of the water is separated here. Same charges repel each other and tilting the surface to force an interaction where you can witness the drops resist coming together or a repulsion force. And I can discharge them with my hand. We're going to do the same thing, but this time I'm going to use food coloring to make the water blue. It just allows you to see it better and it just looks cool. It's one of my favorites. I couldn't do this on the first demo because people would think that the blue stuff in the water is making the water act weird. So that is why I started out with the clear water first. Already you can see discharging here. I made an adjustment to get a larger sample, and it is evident that this water has a charge. The water in this state is extremely unstable. It responds to grounded objects to draw electrons from them. Anything or anyone grounded provides electrons to bring them back to a normal state. I also wanted to show you what happens to positive charged water in a magnetic field. These are not fancy neodymium magnets. This bar has about 4 of the weaker ceramic ferrite magnets on it. Here is another example of the water reacting to my hand. There is no tilting of the surface like the first examples. The water will discharge over time depending on how insulated it is from other objects and the air. This is a close-up where these drops are still sitting on a layer of air. With your hand, instead of a repulsion force like you saw between droplets, one will witness an attractive force to the point of shaking. Because the water is positive and my body, when grounded, would be the opposite or negative. The next vessel is a stainless steel tumbler. After the water goes through electron extraction, it accumulates and charges this tumbler, and you can see the effect of the hair on my hand before there is a spark. For every 30 milliliters of water, which is about 2 tablespoons, there is about 30,000 volts or 30 kV, and that is great, but these cells are not as efficient as they can be and are going to be. As a citizen scientist, I have come as far as I can for one person. You can contact me at CloudFireEnergy@protonmail.com. I also have a website that's in progress, CloudFireEnergy.com. Electron extraction opens up the door for new opportunities in energy. There are at least 4 sources from electron extraction. I've demonstrated the electrical aspect to some extent, but there could be more than 4 depending on how things are categorized. It also opens up the door for new opportunities in health. You can just search for negative ions or the effect of negative ions on health. And there are some other health impacts that I can talk about at a later date. And another is chemical and material science. A lot of chemical reactions in various industries use water. What happens if you use water that's missing its electrons? What happens if you present those electrons in the middle of that chemical reaction? You can get an idea that the possibilities are endless and a lot of things need to be investigated. Thank you for watching this video. CloudFireEnergy.com.